All right. So hello, everyone. My name is Viraj Chandra, and we will be doing post-contest discussion for Codeforces Round 943, that is Division 3. All right. So we'll be doing problems till G1. So that's around 7 problems. And we'll be discussing all ideas. You guys are free to open your mics and tell me all about today's contest. All right. Let us start. So problem 1, A maximize. So it's a pretty easy problem like to read itself. Like you are given simply an integer x and your task is to find any integer y between the range 1 to less than x. So it cannot be equal to x exactly, such that the GCD of x and y plus y is maximum possible. So now this is a pretty, like, it's a pretty good equation. You are given this equation that clearly make my GCD of taking my current x comma y plus y. Make this as large as possible. And in this, y cannot be equal to x, right? And that makes sense, right? Because if that's the case, then this is even not even a diff4 problem then, because like then you can actually take y equals to x, and then GCD of x and x will be simply x plus x. You will get a very big answer that is actually 2x. And I don't think you can cross that. So that is why they have told you that y should actually belong in a range from 1. And then, so you can take 1, that's definite, and you cannot take x. So it's a like a circular braces there and a square bracket over there. Clear, everyone? So now, what are your general ideas on this? Like, first of all, like when I read the problem, my first intuition got into my head is looking directly at this thing. Like, they did not give me the capability to use x, did they? They did not. And if they did not give me a capability to use x, that means they were trying to tell me that you cannot take x, because if you would have taken x, you would have gotten something that looks like x plus x, which would have given you 2x. Is that right? So now, like before even diving into the main idea, if you look at the constraints are very small, right? So like if you have to report an answer y, which is belonging to 1 to x range, and x is in 1000, can you brute force this answer out? Yes? Do we think we can brute force this out? Can I simply say that I will run a for loop, and in that for loop I'll run a y iterator, and with that y iterator I'll be able to picture out that what is the current equations maximum am I getting, and if I'm getting a better max, then I can store this y as my potential answer and I can print that at the end. Yes, this is one option, and it seems pretty decent, right? It seems pretty decent idea to implement during a contest. But then if again you are like, you can think very clearly in this, so as to how can you approach this problem in a more efficient manner. What if, let's say, x was a very high value? Then the next argument stands is by this idea. Starting off with this intuition that, let's say, I was not given the capability to use x and I was not doing a brute approach. That means indirectly I was trying to create something that is 2x. Now I cannot reach 2x, but I'll try to almost reach 2x. That is as large as I can go. Now tell me, like generally in your intuition, tell me which is a safer bet to play. Like in this, you have two terms which are getting added. What is a safer term to play with so as to maximize your net answer? Do you think if you keep a very large y versus you keep something that is a best combination of x comma y as a GCD, which is the best optimum thing can you get as a total sum? It's like obvious that I should better play with y. Why? Because like, let's say I was not given the possibility to keep y. I should not keep y as a x value. I know that any other value below y, the best next GCD I could have actually gotten would be something much lower. Yes. So it is obviously better for me to actually say that I will get a GCD which is much lower than this. And then when I add on to that a great y, I will receive a number. Let's say I'll call that n1. Now, idea is, let's say I go the other way around and try to play along with this y value, which is this single term which is getting added. And I say, let me try to maximize this y individually. That means what I can do is I can keep y equals to x minus 1. Can I? When I do this, I will see that the GCD of x and y will turn out as 1. That's definite. Because I know consecutive numbers are going to give me a GCD 1. Yes, I know like 2, 3 give me a GCD 1. 3, 4 will also give me a GCD 1. 4, 5 will give me a GCD 1. Is that right? So consecutive numbers give me a GCD 1. And then if I add on to that x minus 1, sorry. So I'll get a total sum of x. Is that right? If I keep y equals to x minus 1, and I get a GCD equals to 1, y equals to x minus 1, then isn't the sum x? Now, can you argue that you can create a greater sum than this? No. Is that true? Can we all understand that? Because let's say I take any value that is below, like let's say, all right, Mohit. So let's say think of a value that is below, like after x minus 1, what are your next options to go? Next options are you go to x minus 2, x minus 3, x minus 4, so on, so on, so on. Is that right? Is that right? Now, let's say I'll talk about the just next value. You have x minus 2. Now, if you keep this as x minus 2, x minus 2 plus something over here, this is something over here, equals to some number n1, which we just talked about. Now I know n1, I have put a cap on n1 equals to x. Now, if you want that you still receive n1 equals to x, don't you think you should get a GCD 2? Is that right? You should get a GCD 2. Yes. If you get a GCD 2, you will have x plus 2 minus 2 equals to x. That is your n. Is that right? Now tell me, can you think of like you can think of any case, like let's say x was given maybe let's say 6 to you. Then maybe you can pick up 4. You will get a GCD 2. Is that right? And you can keep 4 as this. So you still get an answer x. But can you see, can you go above x? Like, can you, like in this case, you have created a GCD 2. Can you create a GCD greater than 2 in this to cross a limit of x? You have taken the number, one number is x, other number is x minus 2. Between a range of x and x minus 2, do you think it's any, can you think of any pair for the x and x minus 2 numbers such that their GCD is greater than 2? Can you do that? It's not possible, right? Exactly, because GCD of x comma y is always less than equal to x comma y. So that is not possible. So that means I cannot create such a complex, like I cannot create such a number that gives me a GCD greater than equal to 2 when I've taken a range of x and x minus 2, or sorry, the numbers x and x minus 2. Same goes for the next application. That means the cap limit on creating the answer is actually x. Now, can we understand this? Yes. So by this, I can have a very small basic intuition and proving in my head that it now becomes very decent for me to just print a number that is x minus 1. So now this gives me a complexity of O of 1. Isn't that right? O of 1. I can just take the input of x and I can print x minus 1 as my answer. Is this clear to everyone? Hello. All right. So, I mean, if you look at the code part, I don't think like it's going to be a very big piece of code to understand. Just take x, print x minus 1. Yes. Time complexity, O of 1. Space complexity, O of 1. Is that right? Can we move on? All right. I think easy problem, right? Now let's move on to problem number 2. That is problem B. All right. So you are given two binary strings A and B, and a binary string is a string consisting of the characters 0 and 1. Now your task is to determine the maximum possible case such that a prefix of a string A of length k is a subsequence of string B. All right. A sequence A is a sequence of a subsequence of a sequence B if A can be obtained from B by deletion of several elements. So I don't think I should go over this, but let's discuss two things very separately. One thing is called substring in this. Yes, or rather prefix. So like prefix is also a substring. So they have given you two terms. One thing is called a prefix and one thing is called a subsequence. And now they are talking about a prefix length on A and they are talking about a subsequence of B. Now prefix is very clear. Prefix means that if let's say I have a string given A1, A2, A3, A4, so on till let's say AN, then I'm talking about prefix strings. That means maybe a prefix string can be till here, till here, till here. So meaning the string, let's say from starting, definite starting from A1, but going up till a character which I please. So maybe it can go till A3, maybe it can go till A4, but it should start at A1. That is the meaning of prefix. Yes, I think that's clear with everyone. Now, what about subsequence? Subsequence also is pretty clear. If I talk about B1, B2, B3, B4, so on, something being as till Bn, this is a string B. Then if I'm talking about a subsequence of B, that means I'm actually selecting some characters out of this string B and I'm concatenating them together to create a new string. And because those characters can be taken from anywhere, only and only considering that I maintain the order, that means it's a subsequence. So that is what is written over here, possible deletion of 0 or more elements from anywhere. So I can say, maybe I can take B1 in order. Then maybe let's say I don't take B2, B3. I want to take B4. Then maybe let's say I take B5. Then let's say maybe I take Bn. So this is a 4-lengthed subsequence I have extracted from the B string. Is this clear to everyone? Can you move on? So now you have been given these two strings. This is A1, this is A2, A3, A4, A5, let's say till AN. And you have something as B1, B2, B3, B4, B5, so on till Bn. Now, typically, I would think that I want to create the maximum k-lengthed substring, or rather prefix, from the string A, which matches a subsequence in B. So let's say I argue that there was a 4-lengthed substring from the start of A, that is A1, A2, A3, A4, that matched with the subsequence in B. So what would that actually mean? That would actually mean that somewhere in this B string, I was able to map A1 with, let's say, some character, let's say B2. A2 was also present, let's say, some character at B4. A3 was, let's say, present somewhere at B5. And let's say A4 was present somewhere at Bn. So this subsequence, which I extracted out of B, that is B2, B4, B5, Bn, this turned out to be equal to the prefix string of A. Is that right? Is everyone catching up till here? Now, why am I drawing such a diagram is to actually get you through the implementation and like a straightforward derivation of how would I have actually written the code piece of this. Can you see I've drawn lines over here and I can picturize the mapping. So what does this indirectly is trying to tell me? It's indirectly trying to tell me that, let's say you start off with 2 pointers over here. Let's say you keep a pointer j equals to 0 and a pointer I equals to 0. And let's say you have a current length matched as, let's say, you can name that as k. K was the length I was trying to match. It starts with 0. So currently no length has been matched. What do you essentially want to do now? When I said that A1 was mapped with B2, greedily, I would have argued that A1 would have been mapped to B2 because A1 would have been not equal to B1. Is that right? Let's say I wanted to match the initial prefix length of 1. Then let's say A1 was 1. B1, if B1 would have been 1, can I map A1 to B1? Yes, because that is matching over here. And then maybe I can move my both pointers above. So I can say maybe if that happens, move I++ also and move J++ also. Because I have matched one character from A up till a limit to some next character in B. But what if this B1 was not equal to 1, it was actually equal to 0? Then what would you have done? You would have said, all right, not an issue with me. Then what should you do? Run this J pointer till you actually find a B character which matches with A1. Because I want to make a prefix length initially with 1. So I know that my equation, my implementation part is kind of looking in an approach of 2 pointers. Is this approach clear to everyone? 2 pointers. Can everyone imagine this? Yes? Why 2 pointers? Or how exactly 2 pointers? I can start off with, as explained, I can start off with I equals to 0 and j equals to 0 as 2 pointers in the string A and in the string B. And then I have a current length k which I'm trying to create. Now, what can I do? I can say that if I find that this current A of I is equal to this current B of j, then I know that tells me that my current k has increased and I can move my both pointers forward. So this becomes I++ and this also becomes j++. Both pointers have moved. But let's say that is not the case. Then what do I need to do? I need to run maybe a while loop telling me that increment j till I find this equation not satisfied. Is that right? Can everyone imagine this? So what will essentially happen? You will be incrementing j in a while loop till you don't find equality. As soon as you find an equality, you break. And now if you have found an equality, you will try to actually increment the current k length and as well as I and j. Can everyone imagine this? So like, let's say I run this on a code. Let's say I run this on a piece of algorithm. This algorithm on a piece of code. Let's say I want to calculate for the last answer. All right. So second last answer. This is 100. And you have 11010. Is that right? Now, can everyone imagine this? I starts with 0, j starts with 0. And k is initially 0. I'm standing at I0, J0. I match a letter. Because I match a letter, I say k becomes equal to 1. And now both I like I was over here and j was over here. Now both I and j can move forward. So I comes over here and j comes over here. Now I see that I and j don't match. That means I need to move my j forward till the time I'm able to match them. So I move j over here and I see, voila, they match. So I can map both of them together and I can say now k becomes 2. And now both I also move forward and j also move forward. So I also moves forward and j also moves forward. Now again, 0 with 1, not matching. Move j again. When I move j, till I was having a while loop of inequality, j stopped over here because now everything was matching and it could have been paired. And then k becomes the new value 3. So in this, I can clearly see that by this mapping over here, you can very clearly picture that I was able to find a 100 prefix string, or rather the whole string rather than A, with a subsequence with B. This was B and this was A. Is this clear to everyone? Now, can we look at the code part? Yes? All right. So this is going to be the code. Yes? Now, what I have done, taken N and M, taken the input A and B string, pretty simple. Now I've taken a J, I should say a pointer, that is 0, and I pointer is running in the for loop. You can again do this with I and J separately and then run a while loop, or you can run a for instead. So this is a 2-pointer approach. Typically, it can be implemented in any method. Like first you understand the idea. If the idea is clear, then implementation is not a big part. Yes? So starts off with k is my answer. Then I have a for loop I equals to 0, runs till n. I extract this character that is spaced at a of I. Now I'll first run this while loop to actually check is j less than equal to m and b of j is not equal to character. If that is the case, then till that happens, increment j. Now, while doing that, if you actually cross the limit of the B string, that means j was actually equal to m or rather greater than equal to m now, if you understand that well. So you can break out, because that means now you have exhausted the whole B string. Now you cannot form any more matchings rather. So you break. Else you can increment your k and you can increment your j by 1. So I is always incrementing. In every loop, you can see I is always incrementing. So we just saw that I should always increment because it's always going to match somehow or the other. And if it doesn't match if it doesn't match, that means somewhere or the other you have exhausted the B string. So you will break out eventually. And then you can print your k and it is going to give you a right answer. So you can see it's running over here also in the right cases. Yes, and it will definitely get you AC over there. All right, so we'll be actually sharing the codes at the end. So all is going to be cleared then. Can we move on to the final problem, C problem? Yes? All right, good enough. So now C problem, assembly via remainders. Now this is actually, like, I should say, a very observation and pattern based problem. Like today's in contest, even for C, even for E problem, I should say, there were a lot of observation and general pattern building, right? So if you can build a pattern in this by some mathematics logic, you will be able to answer this. So I'll be sharing my idea. I think that will be, like, if that's your idea, then it's pretty cool. If that's not your idea, then maybe you will find this idea pretty interesting, because I have kept a very straightforward approach. All right. So problem is very simple to understand. You have been given an array. Now this array starts with x2, so don't get confused in that. What they mean is exactly, if the n size is given to you, you have been initially given n minus 1 elements, right? Starts with x2, x3, so on till xn. And your task is to find any array a1 till an. So you want an n-sized array. Every element has a very large element. So this is one thing I just observed. It was given that AI is very big. AI can have ranges from 10.9. And then other thing is given that you will make sure xi is equal to AI mod AI minus 1. Now, what is the meaning of this? We can actually look at the test cases and we'll understand that. All right. So we understand what is mod, right? That's not a question at all to picturize what is mod. Mod is giving me remainder, right? So now what happens is, like, let's say they have given you the first answer 241, and the answer to this is 3549. What they mean is, if you start taking 2 pairs, you will understand that you are getting a basic mod. That means, like, in this, all right, so like, let's say the array was actually 241. And then your array, which you could have formed, like one of the potential answers is 3549. So in this, if you take 2 pairs like this, then you will say that, and you take like this as the number one and first number, and this as the second number in a pair, like the later number as the first number and the before number as the later number. Then you will say that 5 mod 3 for the first pair turned out to be 2. And then similarly for this, 4 mod 5 turned out to be 4. And then 9 mod 4 turned out to be 1. So I got an array that looks like 241. Is that right? And it matches. So I simply want to create something like this. So I think question is pretty simple, right? Question is pretty simple to understand. Now, what ideas do you think I can actually create in this? Like, first observation I can very much see is I have a very large limit on AI. When I say very large limit on AI, compared to what the numbers are given, that is xi, I have a very large limit. I did the same, but added it to the, I did the same. All right. So somebody saying last element is 1e9. Yeah, right. That makes sense. You're going in the right direction. I mean, like, people are getting this approach, right? We are getting this idea. All right, Weber. All right. So Weber was given an approach, right? Cool, Weber. I think you have well understood the question. But like, let's say we want to, like, all right, I can see you have done a very basic approach of taking the previous number and then adding on 1 to that number, right? So you get that idea, right? You are trying to create something like that. Exactly. I'll be doing almost the same idea. Let's see what I'm doing. What I'll do is, in this case, I can very well observe that AI is very huge. So I have a very good limit on AI. Is that right? And then, but compared to which xi is very small. I only have 500 limit on this. Is that right? Along with n also being very small. So let's say, first of all, I'll argue that the last number given to you, this is 1, this is 1, this is 2, this is 500, this is 5. Like, do you think, like, even if you don't hamper that number in the last of your array, you will be good to go? Like, what I can do is I can start off by building a pattern, and I'll say, if this is A1, this is A2, this is A3, this is A4. Let's say I add 4 numbers in this, or I'm sorry, let me talk about in X formats. So let's say this is X2, S3, X3, X4, and X5. So you wanted to create 5 numbers. What I'll do is I'll copy paste X5 over here. Any problem with this? When I'll copy paste X5 over here, the next number which I would want to copy paste to create, like, because I want to create, like, this is an array of 5 places. I have just filled the 5th position. Now I know that the 5th position being X5, if I want a mod X5 over here, that means something X5 mod something over here is giving me X5. Is that right? So I think that is what many of you must have seen or observed. That for the last number, I can maybe put something like this, that I want a very big number, which actually gives me X5 back. Or that actually applies to every number per se. But like, to more simplify things, what if I take this number as 10 power 9? Like, because I know that this numbers, X numbers are giving me a limit in 500. Is that right? So any highest X is given me is 500. If I take the last element as 10 power 9, then will I be good to go? I know that whatever happens, I will definitely get X5 back, because X5 being, let's say, even if it's 500 mod 10 power 5, 10 power 9, sorry, will give me 500 back. Or indirectly, a concept being that if you're taking X mod something, and that something is like this something over here is actually greater than X, then you will get X back. That is pretty simple to understand. Yes, if you're taking X mod something and you want X again, then you can very well, like, for a safety, keep that something greater than X. Then you will always receive X back. Yes. So I have applied the same idea. I can put 10 power 9. That's a viable answer. And I can, because of that, I will definitely receive my last number back. So this is 10 power 9. Is that right? Is that good to go? Now, what will I actually now print further? Like, let me try to tell you this. Let me try to tell you the intuition why I saw this. The same approach that, let's say there's a number X, and I want to mod it with something so that I receive X back. So mod should be greater than this X value. Oh, sorry, this something should be greater than X value. This is something, let's say this is S, so S should be greater than. So now let's say I kept 10 power 9 over here. And now I wanted to create X4. That means what I wanted to do is 10 power 9 modulo something should give me x4. Is that right? Is this what I'm trying to form? Yes. So tell me, if I keep a number 10 power 9 modulo, if I keep a number 10 power 9 minus x4, then do you think I'll be good to go? Can you think this? Yes. Let's say I keep 10 power 9 minus x4, then will I get x4 back? I will, right? Because 10 power 9, like let's say 10 power, like let's say x4 was actually, let's say 7. So this is number 10 power 9. I am going to do this with modulo of 10 power 9 minus 7. So the difference between 10 power 9 and 10 power 9 minus 7 will be 7. And don't you think you will receive that 7 as a remainder difference with x4? Yes? Or you will receive x4 as 7. Is that right? And do you think this is always going to pass? Like, because x is given in a maximum limit of 500, then even if this x turns out to be 500, will I still receive 500? Yes? I will. Can everyone imagine this? Yes. And now, because I was wanting only 500 numbers, so what can be the worst case? You want 500 numbers, your last number was 10 power 9, and every number was, let's say, 500 only. So maximum you would have decreased from 10 power 9. So after 10 power 9, you would have, let's say, placed 10 power 9 minus 7. So this is a new number. Now, let's say you wanted x3. So you will now place 10 power 9 minus 7 minus x3 over here. This will give you the mod of x3 again. This can be 10 power 9 minus 7 minus x3 minus x2. So this pattern can be followed. Is everyone clear with this? And maximum, the first number can maximum boil down to a limit of 10 power 9 minus 500 square. If I'm not wrong, right? You're decreasing 500 every time. Yes, almost. Correct. Almost like that. Yes. So this is also going to be a very huge number, because like 10 power 9 minus 10 power 4 order number is still going to give you a very huge number still in an order of 10 power 9 only. In an order. Again, I said order of 10 power 9. Or maybe like 10 power 8, but it's still very big. So you will still be in the limit of printing numbers from 1 to 10 power 9. And you will get the right answer. Can everyone imagine this now? So is the proof part clear for this? Why is this happening? Why is this working? Yes? So if I look at the code part, is code going to be pretty clear? What I'll do is I'll take the input of n, take the input of the array, n minus 1 size, take the input of the array, ai. Now I'll create my answer vector. First, I'll push a of n minus 2. Why n minus 2? Because elements are n minus 1 in the array, and I want the last index that would be at n minus 2. And then I'll push back 1e9. That's the highest element. Now I'll run a loop from n minus 3. You can do this mentally in your head to run which iteration you want, from which iteration you want to start. Greater than equal to 0, I minus minus. And every time I'll push back the whatever is the back value, that is answer dot back, minus a of I. So it gets updated every time. Is that right? Now, once I am done with that, remember, I have calculated the answer array in a reverse format. So I want to reverse it again. So I will reverse this array out, and then I will print this array. So I'll get something that looks like this. And you can cross check also. Like if you print this out, let's say for this answer, look at this. You got 2, then you got 1e9, then you got it 1e9 minus 1, 1e9 minus 1 minus 5, 1e9 minus 1 minus 5 minus 2, 1e9 minus 1 minus 5 minus 2 minus 4. So if you take run this iteration on this, you will be very easily able to see that, yes, I'm getting the right answer. Mod this value with this value, you will get 4. Mod this value with this value, you will get 5. Mod this value with this value, you will get 1. Mod this value with this value, sorry, you will get 1. And mod this value with this value, you will definitely get 2. So you will receive this 4, 2, 5, 1, 2 array back. Is this clear to everyone? Yes?
Can I also discuss my approach? Like it is very simple.
We can be quick in this. All right.
Yeah, I'll just brush it up.
All right. Please go ahead.
So like once can you please open that where you have discussed? Yeah, where you have written something before. So here we have x2, x3, x4, and x5, right? So for
Right.
x2, and we also have a1, a2, a3, a4, and a5.
Yeah. Right.
A2 percentile, a1 should have to be x2, right?
Correct.
So a1 should be at least x2 plus 1, and a2 should be at least x2 for this to happen.
All right. So like you,
Did
if
you
you
got
want
it?
x2 over here, you can keep x2 over here and you can keep x2 plus 1 over here. Yes.
Like this has to be minimum,
Yeah.
minimum
This has
like
to be minimum.
basic. Yeah.
Correct.
So for each and every x2, x3, x4, x5, I'll for each and every index in this array, I'll make the minimum value which it should be to satisfy all the conditions.
All right.
So I have pasted the code, right. So first part was doing that thing,
First,
and
about
in
finding the
second,
minimum, then you can increment this by some offset, right?
no, yeah. First, now after this first value, I'll let it be like that because it does not have anything. And
Hmm.
from second value, like let's say in the first test case, first value I got it as it has to be x2 is 2, x3 is 4, and x4 is 1. So a1 has to be at least 3. So I'll start from a2, and a2 a2 has to be at least 5 here, at least 2 here, right?
Correct.
So what I'll do is I'll take next thing I have fixed first one as 3, and
All right,
second
all
one,
right. I got your
yeah,
idea.
yeah,
I got your idea.
did you
All right.
yeah,
Correct, correct,
yeah,
correct.
yeah,
So I think this works, right? I think everyone has been able to like catch up with this thing also, like what the code he's given. All right, he's trying to find the minimum out of this, and then he's trying to find what is the like maximum you can like seal value you can actually find. So like that's a pretty simple mathematics of dividing AI with AI minus one, and then that is what he makes as AI. Yes, but like I mean, this approach typically of finding the first value first and then maybe making something later on is like a very like typical mathematics. Agreed?
yeah, yeah. Agreed.
Kind of, right? Like let's say like let me try to compare this with that thing. Then don't you think this
So
is very like a slightly a difficult mathematics?
like that why I'm multiplying it with that is that thing is like sometimes if AI has to let's say if AI has to be minimum of 5 and
Hmm.
AI minus 1 is 3, so uh, you A1 percent, sorry, A2 percentile AI has to be x2, right?
Got
So
it.
you have
So
to
that's the
multiply it with some term, and
correct,
you have
correct,
to add the remainder. So
correct, correct. So
that
you
that
so you took the back term as multiplication and then added on bi. So that will always make sure that you receive a higher term. Yes.
Yeah, yeah, higher term.
All
So
right.
it is
That's
increasing.
good. So I think overall idea, like the idea is to make high terms. Yes, that's the idea. This is something
Uh,
you are also doing. This is something I'm
yes.
also doing. Is that right?
Yeah, yeah,
So
yeah, yeah.
kudos to that, right? I think if people were able to understand the base idea to actually make high terms, then uh this is like a good thing to go. Yes, exactly, Parishi. That is what I was talking about. Like creating the first element is also good, but then to make sure then always the next terms are always set properly, you will have a bit of mathematics and edge cases. But what if I start off with the last term because I know last term is something that cannot be hampered. So my intuition by experience is always to start with something that cannot be hampered. That is why, although the ideas both are same, I want to create higher terms. I started off with the last element. Does this that is it ever like is it clear to everyone what is happening by that approach and by my approach? So this can be a mental note for you guys, right? You can understand this in like later questions also that always try to focus like when you're creating patterns, printing of like something as an array, something like that. Always try to think of cases which you think are never going to be hampered, something which is not reachable by you, or something which is very easy to start off with. So last element is something very easy to start off with because last element can be itself only. And then I can create this high terms logic. Because now I have a very huge margin on AI, that is why high terms can be created very easily. Yes. So again, whoever like I don't know the name of this. So this approach is also very smart. All right, you figured out something with the first term also. So very well done for that. And I think people who started with the first element also, that's great to hear. You guys were able to make this question. But then again, multiple approaches can be there for every question. Correct. So kudos to this. Can we move on? Works. All right. Permutation game. Do I have pages left? Yes. All right. All right. So in this question permutation game, it was given to you that Bob, like the Bordia, or like Bordia and Sasha had found permutations and an array A. So they have decided to play a well-known game permutation game. And what they clearly want to tell you is you have been given some K turns. So those K turns are applicable to both these players. And once you have been given the array of permutation along with that array of A, that array of A can be treated like no, this is not at all a DP problem, Rajat. All right. So like it's like kind of a prefix sum problem. Now, if you consider prefix sum problems to be 1D DP, then maybe you can complex yourself. But then I don't consider prefix sum as a DP thing. Like it's something which is very easily visible. All right, Rajat. All right. So it's been given that you have K turns for every player, and every player is starting with some position PB and like PB for Bodhya and Sasha for PS. So they have some starting positions. They will try to get along with the array and try to move along those permutations. So what they mean is currently, let's say they're standing at the position X. They can have the option to increase their score by AX. So that's definitely there with you. And the next thing can be done is they have the option to move, either stay there or move to next position, that is P of X. So now this is something that is like moving in I think like imagery of this would be much more clear. Let's say the array was 4, 1, 3 to you, 3, 2 to you. And PB was given, like I'm talking about the first case. So it was given PB as 3. All right. So PB was 3, that is Bodhya's position, and Sasha's position was 2. So if I start off with the third position, what it means is, like, let's say I'm standing at third position, that is 3. Now, when I am standing at this third position, next thing, like, next position, which all right, is this 4, 1, 3, 2? Oh, wait, no, my bad. This is 4, that I was getting confused. This is 4, 2, 3, my bad. So when I'm standing at this position, I have some scores with this. So I have, let's say, x1, x2, x3, x4, or rather in A array format. You have some A1, A1, A2, A3, A4 score with you. So when Bodhya was standing over here, he said, all right, let me take the score and let me move on. And when he says, let me move on, then he will say that I will jump to the next position, which is kept over this place. So this is P of X. So if currently I am standing at the third position, at the third position, whatever number is kept, I will jump to that position. So now the next position is 2. When the number 1 is kept over here, now the next position will be 1. Now when the number 4 is kept over here, next position will be 4. And now when the number 3 is kept over here, next position will be 3 again. And now this is a cycle. So I went from this to back again to this and to this back. Can everyone imagine a cycle over here? Yes? So everyone understands the movement. The movement, what they're trying
But
to do.
it need not be cycle in every test case, right?
Yeah, it will be cyclic. It will be always cyclic. Like there will be, like, if you are trying to say will it be cyclic and it will cover all elements, then that's not true. Like it's not necessary that it will cover all the elements, but it will always be cyclic.
Like if the permutation is 1, 2, 3, 4, then there is no point. Like
Then there's a cycle
so,
itself, right?
yeah, cycle itself.
There will always be a cycle. Like there will always be a cycle of movement. There will always be a cycle of movement. A cycle of movement. Now, it can happen that that cycle of movement, it does not cover every element. Like in this case, let's say the permutation was 1, 2, 3, 4. Then if you start with 3, you will end with 3. Shouldn't it stop at the element with maximum A of L? All it had. That's not the case. That is not definitely not true. So this is actually the difference in the problem. Like at the first glance, you might think that this problem is a greedy problem. Like you might think that what I'll try to make I will try to utilize my turns to actually pull the player to the largest possible term in its cycle, and then maybe I can get the most potential answer. But that's not always going to be the case. What if, like Hardik, let's say, like I'll not try to picture you a test case only. I'll try to tell you a statement. I think you will be able to understand that. What if, like as Mohit also said, what if you're never able to reach the maximum element? That is one thing. Other thing is, let's say you did, like, let's say you were able to reach the maximum element, but what if after reaching the maximum elements, the number of turns left with you were not enough to create a answer for Bodhya, if let's say I'm talking about player one Bodhya, in compared to which what you could have done is you could have utilized your turns to not reach the maximum element, but rather take some other position and actually always kept your step over there. Like, can you think of this statement? Like, greedily, if you try to argue this, don't you think that's going to be a much potential answer, like much viable answer to argue? Yes. Like, there can be a case, right? What if you don't have to reach the maximum element always? What if you actually able to create an answer that is better than reaching the maximum element even before that? It can happen, yes. Because you have k turns. It's dependent on k. Is that right? Hello. So like this can be the route for everyone. People who must have tried to run a greedy approach, they will get a wrong answer directly on wrong answer too, on maybe even on the first answer. All right. So that is why I cannot use an approach like this. So what more do I want? Like, what do I now want in my logic? What I actually want in my logic is, let's say I have been given k turns. So that is pretty clear with me. I have been given k turns. That means players are playing. They are trying to jump k times. So what I can do is, first I can calculate the path on which, I'll say path B, on which Bodhya can try, on which Bodhya can run. Meaning, in this case, let's say Bodhya started with 3. So I will add on the values in the path B for which I feel that Bodhya can run. So in this case, the values given to you, they were 7. All right. So this was 7, 2, 5, and 6. So what I'll do is, I'll remove this permutation. This is no longer my permutation. Can you see that in, let's say, k equals to 2 turns? In k equals to, given that, let's say, k was 2. So k was 2. In k equal to 2 turns, Bodhya can jump from the value 5 next to the value 2. For that, if current Bodhya index greater than current's such an index, then change the index for Sasha, otherwise don't move. No, that is also not going to be the case, Rajat, because like you can again find a counteract of this. Like the best answer to this is actually finding all possibilities. This is why I think maybe you also pointed out that you think this is deep. All right. So exactly, George. Exactly. That's what I'm trying to tell. No greedy approach will work in this because there is no direct greedy approach in this. Because for every greedy approach, like you cannot argue that I will try to stick at an index or try to move from index by a greedy logic. That's the argument. Because you will always find a counteract to that. Best possible case is you try to like I should say, explore all the possibilities of creating an answer, and that will be the better option. Let me show you how. What I'll do is, first what I'll do, I will create the path of B. So path of B, as in how much B can travel, irrespective of whatever K was given. So I'll not first consider K, forget K was given. How much can B travel before coming back to a cycle? So it can travel, start with 5. It will jump to the next index, that is 2. 2 will have a value 2. So this is score 2 rather. 2 gets added. Then to index 1, 7 score. Then back to an index 4 that has a 6 score. And then again, when you jump back to 3, you will say, I have reached a end of a cycle. Yes. Now I have reached an end of a cycle. Yes. So this is the path of B. This is the path of B, maximum path of B, which Bodhya can travel, so that he doesn't now get into a like endless loop. This is where he can end. After this, you know there is an endless loop. Yes. If I calculate the same for like path of S, what can that be? With 2, then I have a value of 7, then a value of 6, then a value of 5. Is that right? Yes. Now tell me, I have taken the whole path. I have taken the whole path. Now let's say K was 2. Then when I say, for all those people out there, when I say I will try to explore all possibilities, what does that mean? It would mean that given K was 2, first I want to calculate S1, that is the sum 1 for Bodhya, and then S2, sum 2 for, or score 2, sorry, for Sasha. So how do I calculate S1? There's no point of going to cycle 1 straight math. Yeah, that is true, Vaibhav. Like there is no point in the cycle when the max, but again, to hit max, like you are talking about a case when you feel is greater than S and not stop at the max element. You will stop max element. Like you will, like indirectly, you would have stopped at the max element. That is definitely an argument. Like let's say you reach the max element somehow. After that, whatever left number of turns there are, it would obviously make sense. After that, greedily, it would make sense that you want to create that max element left over with k turns. Yes, that's true. But the argument was, what if before reaching the elements you did not had k turns, as you pointed out? Or even if you had k turns, what if you had the capability to create a larger term even before reaching the max term? Can yes. Like let's say there was an element, like let's say the maximum element was kept over here, m, and then there was an element m minus 1 kept over here, and let's say you had k equals to 8 turns. So if you spend all the 8 turns at m minus 1 versus you travel a path of let's say maybe 6 elements, and then all those elements are very small, let's say maybe 1 2 3 small elements, and then you reach m, which is better, sticking at m minus 1? Yes. So never reaching m was not a good option, right? Or sorry, reaching m was not a good option. You could have sticked it till from m minus 1 and you would have the better answer. Do you understand this? Yes? All I think like people are able to get this idea. Now what I'll do is, when I will explore all the possibilities, what does that mean? I will say that I had two options. I had two options. One option was to keep myself over there or keep myself at a fixed index. So like keep myself at an index. Or other thing was move on. Other thing was move on. Yes. Move on. Now tell me, you cannot basically decide if you should stay or move, just you can go. Exactly, Parishi. Exactly. That's what I tell you guys. You cannot make an informed decision where you want to go. If you want to go forward or current position, you cannot make the decision just by looking at the numbers. Like there is no possible scenario by which you can counteract that. I know after this I have to move, or I know after I don't want to move. That is why you always have to take all possibilities. Exactly, Mohit. That's my idea. Basically, try to stop at each position till reach cycle. Exactly. So what I'll say is, let's say K was 2. I will argue that one possibility, what if I had spent all my 2 turns for, I'm talking about player 1. Player 1 is Bodya, whatever you can call this. So player 1 will say, let me spend all my 2 turns at this current position. Then what sum will I form? 2 into 5, that is 10. Yes. 10 is a possible answer. Next, Bodya will say, let me not do that. Let me spend only 1 turn at this, move on, and now spend leftover turns at this position. So this will be 5 plus leftover number turns are 1 only. So 1 into 2, that is 7. Is that right? This is one answer also. 7 is answer. Let's say K was 3. Then what can be the other answer? Other answer can be took 5, took 2. Now whatever is left over, spend at this. This is 7. Yes. So that would give me an answer of 5 plus 2 plus, like if K was 3, then my answers would have actually looked like from the starting 15. This is one possible answer, sticking everything till this index only. Another case, only take this once, then use leftover turns at this position. So that would be 5 plus 2 into 2, that is 9. And then other case would be use 1 turn over here, 1 turn over here, and then stick whatever leftover turns are there at this position. That will be 5 plus 2 plus 7. That gives you 14. So what would be the better case? Better case out of this was definitely 15. So you are printed out 15. Can you understand what I'm doing over here? Can we now understand the ideology of, I should say, taking all possibilities? Am I taking all possibilities in this case? Yes. When I'm standing at a current index, I'm arguing that whatever leftover turns that were given to me, let me spend those at that index. That is one possibility. Other can be I move on from that index and then I calculate rest of the things again from the next index. And out of this, whatever maximum possible scores I can achieve, whatever scores I can achieve, maximum out of this becomes S1. And then this is obviously done till I'm able to exhaust K. Either either I'm able to exhaust K or I first exhaust the array, cyclic array, or which I've created. And then this same thing can be done for Sasha. I noticed that in the contest, but I couldn't think of an approach or implementation. All right, George. So I think this is clear now to you. Yes? Same thing that can be done for Sasha. How do you keep a track of all values? Track of all values means, Vaibhav? Take max. All right, I'm taking max. Yes, correct, Mohit. So Vaibhav, I'll show you the implementation. You will realize what I'm doing. All right. I'll show you the implementation. And then once let's say I've somehow found S1 and S2, that is the maximum Bodhya can do, maximum Sasha can do. Then it becomes a pretty simple if and else check, right? S1 greater than S2, print Bodhya, S1 less than S2, print Sasha, both equal, print draw. Correct? So now can we actually look at the D problem? Yes, implementation. Like, let me, I think I skipped this part also. Even I skipped for this part also. I did not discuss the time complexity for B and C code. Like, should I do that quickly? 5 minutes? For all those people who might require that. All right. Now. All right. I think like B and C questions are very good. All right. So no need go with D. Cool. So let us look at the D implementation. I took N, K, PB and PS input. Correct? Now I took the A array and the score array input. Things are pretty clear up there. Now I want the path B and the path S. So for that, I will created a visited array that is kind of maintaining that cycle. Everything in this as an index is 0. So I have a 0-based indexing. That is why I'm maintaining PB minus 1, PB minus 1 over here. So don't get confused with that. Now I'll make my PB minus 1 index initially as 1 because I know this is visited. Now I'll go in my while loop till it is true. I know that till it is true, I will want to create that cycle and add on the scores. That is, I want the score array coming out, right? 5, 2, 7, 6. So what I'll do, I'll push back in the path score of PB minus 1, make my current BP as the number kept at A of PB minus 1. And then if this number PB minus 1 is already checked or it is marked 1, it is already visited, then you know you can break. Yes, because that means you have reached a cycle. From this, after this, you know, you will have an endless loop. So you can break over here. Same goes for this. Now, once you have done this for the path of B, you can find the same thing for path of S. Yes, I will initialize my visitor array back with everything 0 and do the same thing with PS into consideration. Push backing score in path S. Now I have two variables, BS and SS. BS means score of Bodhya and SS means score of Sasha. And I have a pre-variable. Now this pre-variable is actually the prefix sum variable, or you can call this as pre-sum variable. Now what I'll do is run a loop in the path. When I think that I've exhausted the K limit, that means I plus 1 has become greater than K, then I will break. Is that right? Is this statement clear? I think there should be no issue with this statement. Yes? If I think that I plus 1 has become greater than K, then I should break. Yes? Because I know that I have exhausted my number of turns. So if that happens, that my current I plus 1 means in one-based indexing, it turns out to be greater than the K turns given to me, I will break. If that is not the case, then what should I do? I now need to create I want to create the best current score. So I can mark this out for you guys like this. I can say my current score is actually equal to this value. Can everyone imagine this value? Current score is going to be whatever is the previous sum, prefix sum, which was maintained, plus however number of rounds are left with me into the current value. So the current value is kept at path of B into K minus I is going to give me the current round count. Let's say I was standing at I0. That means I have K rounds total. I was 1, so I have K minus 1 rounds. I was 2, I have K minus 2 rounds, so on, so on. Plus Pre-sum means whatever back term was there. So let's say up till here, I was talking about this. So this prefix sum would have been 7. 7 plus, this would have given me 7 plus 1 into 7 for a k equals to 3. Here, what if k is greater than equal to I? If k is greater than equal to I, then you will exhaust the array first, right? If, let's say, all right, Vaibhav, tell me, if k is greater than I, then what is the best possible case? If k is greater than I, then the best possible case definitely is you will be traveling the whole path. Yes, whole cycle. And you will be reaching max somewhere. So will that not give you the viable answer? Like, let's say in this, like, let's say 5276. In this, the max number is 7. Let's say k was given very huge. Let's say k was given 1000 to you. Then what would have happened actually? You would have gotten a better answer at this position 7. Yes. And the best answer actually. So you're also indirectly considering that case only. When you actually talked about the solution that what if I had a very large k, or what if I was trying to reach the max number first, then don't you think that case is also covered in this? Yes. Can you imagine this? Got it? All right, got it. So this can be done for the current sum, and this can be maximized with BS. And then I can increment my pre-sum by path B of I. Now, this is how I found BS. I can initialize pre-sum back with 0, and I can do the same thing for SS. Yes? Can I do that? I can maybe call this as S. Can I do the same thing with the Sasha's SS score I'm trying to calculate? Yes? Pre-sum. And then when I come out of my 2 for loops, don't you think I will receive the best possible score? Implementing it with a separate function would have been good and looked neat, but I have also written everything twice. All right, so like Vishwas, that's a very good point. All right, and I'm sorry for that if that becomes a bit not clean in your part, but like this is the problem. I was trying to, like, in my mind also it was being the part, right? Like I am trying to write code very quickly because it's a contest for me also. So I skipped over the whole concept of making it as a separate function. But again, you can definitely do that. And even like that's a good point. What I'll do is actually when I actually paste the final code in the video solution itself, I will give you a function based algorithm. All right, Vishwas. So thank you for pointing that out. Cool. All right, Vaibhav, how much would be rating of this question? Like I should at least rate this 1300 to 1400 to 1500 maybe rating question. Like if I'm not wrong with this, because like there is something as prefix. Can you just give the argument like why don't we stop on the maximum number? Akhilesh, we would be indirectly stopping at the maximum number. Like what am I doing till here? Like I'll argue this again. Let's say k was given 1000 to you. Then technically you would have argued that it would make sense for me to stop at 7. Yes. If I did not stop at 7 and if I calculated the other answers also, other answers will be smaller. Do you understand this, Akhilesh? Like, let's say you did not stop at 7. You wanted to stop at 7. I get that. But what if you did not stop at 7? You moved on later on also. Don't you think later on answers will be very small as compared to this up till here, this 7 answer? It will be, yes. So because of that reasoning, can you dry run the code for the first test case? All right, let me do that. All right, George. Let me do this. 1, 2. All right, this was the array. Score was 7, 2, 5, and 6. K was given 2. Path will be calculated. So let me calculate the path first. Are we clear on how is the path calculated, right? Path will be clear to understand, right? Path is calculated on the score. So path gets calculated as this is 5, 2, 7, and 6. This is the path for Bodhya, and 2, 7, 6, and 5. This is the path for Sasha. Is this clear? Now pre-sum is 0. Pre-sum is 0. Starts off with 0. I'll talk about this loop. Pre-sum is 0. Is k less than I, like I is 0? I is equals to 0. So I is starting from here. Let me mark this pointer. I is over here. Now when I is over here, is my current k less than I plus 1? No. So what I can do is, I will pre-sum remains simple 0. BS becomes maximum of BS comma current score. Current score will be k is 2 minus I is 1, 0, 1, 2, 3. This is 0. 2 into this value, that is 5. So I receive a BS equals to 10. Yes, George? Now the pointer moves. Now I know pre-sum has now become a value. Pre-sum is now a value equal to 5. I have written this line over here. Pre-sum plus equal to path B of I. So pre-sum gets added with the value 5 and move on to the next value. This is the next value 2. So now you say BS equals to max of BS, comma, total is 2 minus 1 into this number is 2. This number is not 5 now. This is number is 2. Plus, I had pre-sum. Initially, I was adding pre-sum 0, so that was not a point. But currently, my pre-sum is 5, so this gets also added. So now this is 2 minus 1 into 2. This is equal to 2 plus 5. This is equal to 7. So you compare 10 with 7, which is greater? 10. So you stop. You say 10 is the best answer. And now you have exhausted K. Yes, George. Now can you do this the same thing for Sasha's array also? Yes? All right. So I think now now you guys get a clearer picture. All right. Now let us discuss the time complexity for this. All right. You have input taking. So this is running in O of n, O of n. Now this while loop, how many times do you think this while loop can maximum run? O of n, yes. Because like you can visit all the elements and you can stop. So this is also O of n. Similarly for this while loop, maximum complexity is O of n again. You can run all permutations as visited and then you can come back. So this is also there. Now you have a path length over here. This path length can also be in O of n. Inside this, everything is constant. Similarly for this is also path length O of n. Or rather, you can break before k. So you can actually keep a better time complexity. You can say minimum of n comma, or sorry, not n. You can say as path size, path b dot size, comma k. This is a better answer. Yes. Whatever exhausts first. Either you exhaust the path B size or you exhaust the K size. And similar for this. Is that right? And now in that case, now if you finally report the time complexity will be n plus you have that n order over here also maximum case. In this case also you will have a maximum order as like maximum case can be like minimum, like whatever maximum you can go is path B size. So path B size can maximum be n. So you can call this n also. You can even call path size n also. So overall, you can understand, you guys can understand that overall, I can see the time complexity as order of O of n. Yes. Is this clear? Or is there any doubt in this? Do I feel that my current scored order is O of n? O of n. Clear? And now O of n solution will definitely work. Why? Because O of n is an order of 10 power 5. 2 into 10 power 5. What about space? I'm using a lot of space over there, but overall space is also in O of n order. Why? Because I am having sizes of n arrays only, right? N size arrays. N size array for A, score, visited, path, and path is also going to have maximum n size. So I can keep my space complexity also as O of n. All right, so I think the question is well understood. Are we clear? Can we move on? We have good questions to go. Discuss E also. Yes, I'm discussing E. Next question is E. All right. Next question is E. Now, again, this problem E is a very pattern-based problem. There are very few things to understand in this. And like this is by experience, I have solved this problem. Even if you don't get this problem in contest, this is something like how many questions will you discuss? We have E, F, and G1 to go. So this can extend. All right. All right. So let's start with E1. E. All right. So in this, what they were given to you, you have an n cross n array, n cross n matrix. So let's say n was given 5 to you. So you have 5 empty places of a matrix. And now they have told you that you have to place somehow n points in this. Place n points in this. So that if you take, like, let's say this is n equals to 5, and then n, you want n points. Place n points so that the Manhattan distance between any two pair of points, if let's say that Manhattan distance is m, then you want to create a set of those Manhattan distances which are as large as possible, or you want to create the size of that set as large as possible. Meaning, let's say I keep a point over here, I keep a point over here, and let's say I keep a point, let's say over here. Then let's say only I'm talking about 3 points. Then tell me, do we understand what is Manhattan distance? It's given very clearly over here. Manhattan distance is equal to, for two cells x1 comma y1, x2 comma y2, Manhattan distance is x1 minus x2 mod plus y1 minus y2 mod. So now tell me, if I talk about these 2 points, what is the Manhattan distance between these 2 points? 2. Yes. What about these 2 points? Manhattan distance is 3. Yes. 1, 2, 3. Then these 2 points, 1, 2, 3, 4, 5. So I have Manhattan distance 2, 3, and 5 total. Yes, of any 2 random pairs did I take, I founded a Manhattan distance values ranging on a set of 2, 3, 5. So the set size is 3 currently. Yes. 0 also. Why 0? No, 0 is not going to be taken. Like you cannot take, can we take the same points? You want distinct points, right? If I'm not wrong. In the example, we'll notes below. All right, is it given? All right, it's given. All right, all. My bad. My bad then. I did not read this. Then all right, fine. You have 0 also, right? You can take a singular point itself. So you have 0. Not a big deal. Cool. So now the set size is 4. Good that you pointed out. Yes, now the set size is 4. Now, this is the question they are asking. They are asking that currently we place 3 points. You will have the possibility to place 5 points if n is 5 on this 5 cross 5 matrix. And when you do that, create as many as distinct Manhattan distance you can for any 2 pair of points. Again, points can be same also, as pointed out by, who was this guy? Mohit. All right. This is what is given in the question. Now, there is a very wow moment type of a observation in this. All right. And that wow moment observation I'm going to share with you. And if you don't get this observation, try not to get disheartened, because the reason is this comes with experience. Now, the point being is, what I'll try to do is, like, what I'll try to ask myself in pattern-based question, what happens is, first tell me, let's say, I'll start off with my idea. If you keep 1 point, then you have a Manhattan distance 0. Yes. 0 Manhattan distance is there. Now tell me, what is the largest Manhattan distance you can create? 2. Diagonal. Yes, I think people are getting this. If let's say I keep a point over here, so for these 2 points, do you think I will get a Manhattan distance 1, 2, 3, 4, 5, 6, 7, 8? Am I getting 2n, or rather actually n minus 1 into 2? Yeah, 2n minus 2. That's also right. Yes. So the maximum Manhattan distance I can have actually in this case for 5 is actually 8. Yes. Clear, everyone? Now, how many points do I have left? I have used 2 points, and I have created the largest Manhattan distance and the smallest Manhattan distance. Now, my argument is, like, while I was doing this problem, I was always asking myself that largest is 8, I cannot go above 8. Lowest is 0, I cannot go below 0. The leftover Manhattan distance are 1, 2, 3, 4, 5, 6, and 7. Yes, these are the leftover Manhattan distance which can be created. I'm not sure if they can be, but they can be created. Yes, they can be created. Now, my argument will be, I was like, when I was doing this problem, I was always trying to think, let me think, can I actually do that? Like, won't it be very nice for me if I'm able to create all these Manhattan distance? 1, 2, 3, 4, 5, 6, 7, 8. Like, sorry, I created 0, I created 8. That's good to go. But what if I'm able to create 1, 2, 3, 4, 5, 6, 7? Then I will have a set size of 9, and this is the largest. After this, I know after this, the set size cannot increase. So my argument was, I was during the problem, like even on pen and paper, when I was drawing the matrix, I was always trying to think that will it be very nice for me to create all these Manhattan distance? And when my intuition turned towards this head, that let me try to forcibly see if I can come pattern to create all 1, 2, 3, 4, so on till I should say 2n minus 3. From 1 to 2n minus 3 Manhattan distances, is it possible for me to do that? So what pattern did I come up with? Let me try to come up with this wowza moment. All right. First, what I said is, let me target the even, or let's say, like, let me target the even Manhattan distances. So to create a Manhattan distance 2, 4, and 6, it seems pretty simple. What I can do is, I can keep a point over here. I can keep a point over here. This is going to give me a Manhattan distance 2. This is going to give me a Manhattan distance 4. Yes. And then this is going to give me a Manhattan distance 6. So I did create Manhattan distances 2, 4, and 6. Yes. Or other way around, if you can look like something like this. From this, you can see this is 4. From this, you can see this is 6 and this is 2. Either way, like you just saw, when I kept these 2 points, I got a total Manhattan distance 2, 4, and 6 available with me. So these are done and dusted. What are left with me? I have placed 4 points up till here. I am left with 1 point. And I want to create a Manhattan distance 1, 3, and 5, and 7. These 4 are left. 1.2 distance from either diagonal. Exactly, Mohit. So can I keep a point over here? Do you think that solves all my problem? If I keep a point over here, this point which I just kept, when you take its Manhattan distance with this, you will get a 1. With this, you will get a 3. With this, you will get a 5. And with this, you will get a 7. Is that right? Is that right? Can anyone observe this? Yes. This point will add the remaining odd elements we want. Exactly, George. So up till here, I was able to cover the even ones. It was left for me to cover the odd ones. And somehow I forced myself to think of the most optimum point. So this is hit and trial method. I was trying to keep this point somewhere here, and I was always checking like I kept it over here, what happened, kept it over here, what happened, kept it, and then I came up with this point. I said, when I saw this point, I kept it over here. Voila, I was able to form 1, 3, 5, and 7 also. For all n, is it possible to get every distance from 0 to? Yes, exactly, Weber. It's possible now. Because did we not just see this? 0 was always possible. 2n minus 2 was also always possible. Now, between stuff, I made it possible. Yes. So now, even if you expand this, like even if you do this for arrays for n equals to 3 size, n equals to 4 size, you will see this is a good logic to follow. Is 1, 2 also possible? 1, 2. Yes, 1, 2 is also possible. That's also possible. If you kept it over here, right? 1, 2. It's also possible. Because from 1, 2 also you will get 1 distance, 3 distance, 5 distance, and 7 distance. Yes. So this is what I have done in my problem. Now, can everyone understand this? Do you think this is a great observation? Like, again, this can be implemented in any format and there can be multiple answers to this. But like the very straightforward approach I saw was this. And why am I discussing this approach is because during problem solving, like this problem, like I've done this similar problem seriously by my experience, or like I'm trying to share this experience with you guys. All right. So in this problem, what mostly happens is people try to the problem will try to confuse in various arguments. Like in the problem also, they have shown you various permutations, but like they have tried to confuse in this. Your argument will be to come up with a pattern which is subsequent for everyone. So like this pattern can be applied to every n now. Yes. And then the other thing is, because I want to maximize S, what I'll argue is, I formed 0, I formed 8. Then my argument next was like, by experience, I was always trying to argue myself. It would be very nice for me if I was able to create every Manhattan distance between 0 to 8. So because I turned my head in this direction, that is why I was able to come up with this approach. If I did not even think that it is inside me to create such a logic where I can create all such Manhattan distances, then maybe I was then I would have been never able to solve this problem. All right. Thinking in even and odd solved 90% of the problem. Exactly, Sai. Not able to come up with all possible Manhattan distances. All right, Mohit. So that means, Mohit, you actually had somewhere in your gut feeling that it would be very great for me to create all possible Manhattan distances. Yes, but you were just not able to come up with that. So even if you're able to get the gut feeling that maybe it is possible for me to create all possible Manhattan distances from the lowest to the highest range, then maybe you can solve this problem. Because now what is left with you is to simply come up with a pattern which can be applied with every n. Yes? All right. So I think this problem is now clear. Now this problem is very easy. This problem now is much easier than D and B and C to implement, right? If you can look at the code part to this. I will take the input of n, run a loop from 0 to n. Now, I want to omit the case where I print 1, 2. So for that, what I'll do is, if I feel I plus 1 has become equal to like 2, or maybe you can even take this something like this. Like, why do bad stuff? All right. Yeah, this is much clearer. I'll start with I1 to n. Also, it was E, so I was thinking all kinds of, all right, makes sense. All right, so I'll start with I equals to 1. If I is not equal to 2, then what I'll print I and I. Because that would mean I'm printing 1, 1, 3, 3, 4, 4, 5, 5. Yes? And then at the end, I will only omit a point that was 2, 2. And I will, rather, besides that, I will print 1, 2. Or somebody pointed out, you can even print, like somebody pointed out that you can print 1, 2. I can also print 2, 1. That is also going to be a right case. Yes, that also works. And then I can change a line. And by this, you will understand that you can see the points I'm getting 1, 1, 3, 3, 4, 4, 5, 5, 6, 6, and then a point 2, 1. So this is the same thing 1, 1, 3, 3, 4, 4. Like this is for, all right, so this is for 5 answer 1, 1, 3, 3, 4, 4, 5, 5, and then 2, 1. So 5 points. Clear, everyone? Can we move on? What is the time complexity for this? Time is going to be O of n, pretty simple. Space is going to be O of 1, no extra input. Nice. This way easier if you get the observation. Correct, Vaibhav. So like it's all about observation, right? Like when I started the PCD, I said today's like diff 3, diff 4 problems are mostly about observation, because like they cannot hamper you in very crude implementation logic, because like you don't know that implementation logic, right? Like let's say there's a concept of tries, or let's say segment trees, then it is not expected for you to know segment trees for diff 4 and diff 3. So what is there remaining is some math, some algorithm, some observation, some pattern, right? All right, so I'll move on to the next problem. So now we have 2 problems. Now in these 2 problems, there is some algorithm. All right, so it would be expected like for you guys to have a bit of knowledge for this. Even if you don't, I'll try to cope up with whatever I can tell you guys in this. But then the logic over here is kind of very easy to click if you understand this. All right, so I'll talk about F first. All right. All right, so F problem reads that you are given an array x1 to xm, and you are like, it is mentioned that this array is going to be interesting if it's possible to divide the array into k greater than 1 parts. So you don't want 1 part, you want more than 1 parts, so that the bitwise XOR of the values from each part are equal. So it's pretty simple, right? This statement is pretty simple. Like let's say the array is given x to you, and you want to create k consecutive segments, then that would mean that you create one segment, like let's say you have a segment like this, like let's say x array was there. So you created a segment 1, this is segment 2, then this is other segment. So if you find the XOR, this is 1 XOR, this is 1 XOR, and the XOR of 2, 3, and 0 is also 1. So you get 1 equals to 1 equals to 2 XOR, 3 XOR, 0. So the XOR values are now same. Is everyone clear with this? Yes? Are you guys clear with this observation? Like for people who might not be very familiar with bit manipulation. Yes. So now what they have asked is, they have told you, given an array A, answer for Q queries whether you feel the array from L to R is interesting or not. So that means now K is not fixed. First observation. It's not written that you want to create exactly 2 parts, 3 parts, 4 parts. You just want to create more than 1 part. It can be 2, it can be 3, it can be 4, not a problem. And then you want to answer every query very quickly. So like if let's say this problem was not a query based problem, then this problem would have been much more easier. Yes. Then maybe you could have run a brute sort of a logic, maybe where you actually calculate some segments in the array with some DP sort of structure where you were good to go. But then now, because there are queries given to you, you need a faster thing. Exactly, George. We want an O of 1 per query. Like if we run a loop in query in a brute approach, if we run a loop of query, O of Q, and because Q is given an order of 10 power 5. Yes. So inside this, I want a logic which runs in either a constant time or maybe a log in time maximum. I don't want something beyond this. Yes. I want either a constant time. That means I'm able to answer every query in constant time period, or I want a log n period. That means I require some pre-computation. Exactly, Weber. Good to go. So we understand this. We require some pre-computation. we require something to do before even starting off with the logic inside the queries so that I'm able to answer every query quickly. Is this right? Now, before actually talking about pre-implementations, we'll talk about few ideas. Now, tell me, I'll talk about one very common idea. Like, let's say there is an array. So this is an array A1. This is A1, A2, A3, A4, A5, so on till AN. Now tell me, let's say the XOR value, like let's say you are trying to find whether the array bit from L equals to 4 to, let's say, R equals to N is interesting or not. So tell me, like, let's say the XOR value from A1 to A3, let me call this value as X. XOR of all the elements from A1 to A3. Now let me call the XOR value from A1 to AN as Y. Let me do this. Why am I doing this? I'll try to tell you. Now tell me one thing. I have calculated a XOR of all the elements from A1 to A3. That is actually 1 to L minus 1. And I have calculated the XOR from all the elements from 1 to N minus 1. This is N minus 1. Or not rather N minus 1. We are having a 1-based indexing. So this is N. Now tell me, if I ask you the XOR of this segment, let's say this XOR is Z. Can you tell me what is going to be the Z value? Like, you know that X XORed with Z is giving you Y. Yes? X XOR, then Y XOR, Z XOR, whatever the XOR of these elements will give you the net XOR, Y. So if you XOR both side X, like let's say you put XOR over here and you put an XOR over here, then XOR X XOR X, that is same two numbers XOR, gives you 0. Do we all know by bit manipulation that A XOR A is actually 0? And 0 XOR A is actually A. Do we all know this? Yes. So X XOR X will give me 0, which means 0 XOR Z on the right, on the LHS, which means simply Z. So do you think the Z value is actually X or Y? Can I argue that the Z value is actually X or Y? Yes. Can I argue this? X or Y. Now tell me, let's say X or Y is 0. Let's say X or Y is 0. What does that mean? That means that the XOR till here is also X. X equal to Y, correct? Now, if X or Y is 0, that means this segment was also having a XOR X, this segment was also having a XOR X. Now, if X or Y is 0, doesn't that mean that if X XOR Y turned out to 0, that means this segment gave me a XOR 0. There must have been a point somewhere in between up till which there was a XOR Z1, there was a XOR Z2, and this Z1 XOR Z1 had given me 0. Is that right? If it is giving me if this net segment is giving me a XOR 0, does that not mean that there must have been two segments in this segment from A4 to AN which had a net XOR value as 0? Yes. And this Z1 and Z2, if are giving me a net XOR as 0, will that not mean that Z1 and Z2 are equal? Will that not mean? Yes. May not have two elements. It will, like in this case, we are always considering the part that L and R are not equal, right? It is given that in the query, L is not equal to R. So you will always have two elements, Mohit. Got it? So like, let's say Z1 and Z1, now Z1 and Z2 were two segments. Total XOR was giving me 0. That means Z1 and Z2 were equal. Yes. So don't you think if the XOR of the segment from an L to R is 0, the answer is always yes. Isn't this a base case? Is everyone able to understand this? I'm taking one case at a time. Is everyone able to understand this? Yes. If I'll repeat this again, if the XOR from L to R, segment XOR from the segment XOR from L to R is 0, then isn't the answer always yes? Can you blindly tell me that the answer is going to be yes? Yes, because if the segment from L to R has a XOR 0, that means there is always some point between in the segment for which you could have divided the segment into two parts, and those two parts did had an equivalent XOR. That is why their net XOR was giving me 0, because I know only same numbers can give me a XOR 0. Like typically, like I mean, not exactly, like it's always not true that same numbers will give me a XOR 0, but in this case, it would make sense. Yes. Is everyone able to understand this idea? Tell me yes, and then I'll move on. But we have to divide them into K segments. Exactly. So, all right, Vaibhav, that is what I started off with the question. Is K given to you? Like, are you limited to take K as something? Can you take K anything you want? I took K as 2. For K equals to 2, can I see a direct answer? Yes, I can, right? So in my case, I came up with a base approach that when I said, this was an observation, I observed that whether if I found the XOR to be 0 in the segment itself, that means I can form 2 segments at least. Or to be rather specific, exactly 2 segments. And I want greater than 1 segment. So greater than 1 segment condition fulfills, right? Creating 2 segments is good to go. I will create 2 segments. Those 2 segments will have similar XOR because their similar XOR is giving me a net XOR 0. That is why I first started off with the statement that this segment XOR was 0. Are we clear on this? All right. I think I've discussed a lot part on this. Now I'll extend this idea. Now I have created K equals to 2. Now, if I was not able to create K equals to 2, what is the next best segments I can create? Also is 0, then can be divided in even segments. 3. Exactly, Mohit. I can create 3 segments. Yes. So what I can do is, I'll ask you again. Let's say up till here, the segment XOR was X. Let's say up till here, the segment XOR was Y. Big line. Up till here. The segment XOR was Y. So you have leftover segment over here. I'll make this leftover segment. All right. This is a leftover segment. I want to create this segment in 3 parts. Next best case is to create this in 3 parts. Now, ideally, I want that these 3 parts XOR is same. Yes. Is that the case? I do want that. Agreed? Now, I'll give you a wow moment approach. Tell me, if let's say I argue that the XOR, all right, up till this segment was Y. All right. Y 3 in black segment. I created 3 segments, right? I want 3 segments, right? 3 segments. Like this is the segment between L to R. This is L to R. Before L, that is from L minus 1 to 0, there was a XOR X. From 0 to R, there was a XOR Y. And then the segment from L to R, I want to divide it in next possible case, that is 3 parts. So let's say I argued that I put two sticks over here, and I said this is the compartments which I'm trying to create. So this is compartment 1, this is compartment 2, this is compartment 3. I want their XORs to be equal. So let's say this XOR is Z1, this is XOR is Z2, this XOR is Z3. I want them to be equal. Yes. So now what I'll do is, tell me if let's say the XOR value, if let's say this segment was created till like this stick over here, I'll mark this with blue. Up till here, if the XOR was Y, tell me what is the value of Z1? Y XOR X? Yes? Or X or Y, correct? Can everyone understand this? Isn't this X or Y? Yes? Now tell me, if I am able to find the next stick segment for which this segment, I'll mark this segment now. I'll mark this segment with green, all right? So I'll mark this with blue. This is blue. All right, I'll change my pen. This is green. This segment now. Up till here, if let's say my XOR is X, then can you tell me the value of Z2? Can anyone tell me the value of Z2? Like I know that X equals to X XOR Z1 XOR Z2. This is the case, yeah? This X XOR Z1 XOR Z2, this is equal to X. So this is X XOR Y, because Z1 value we just found, XOR Z2 is equal to X. X will become 0. So this is X equals to Y XOR Z2. Now if you take XOR Y over here, XOR Y over here, you will receive Z2 as X XOR Y. Yes? Are we clear on this mathematics? Didn't get it. All right, Mohit. Up till here, the green segment, the XOR is X. Let's say, assume the green segment XOR is X. So I'm asking you the XOR of the segment Z2, this segment, this green segment. Like, sorry, not green segment, sorry, this segment. Tell me the XOR of this segment. I marked this with Z2. Tell me the values of Z2. Z1 is X XOR Y. This is clear. Now, can you tell me the value of Z2 by mathematics? Like up till here, the segment has a XOR X, which will be equal to this XOR, and this XOR. Yes? So that means X XOR Z1 XOR Z2. You are trying to find Z2. Now, you can keep, like if you open Z1 is X XOR Y. We just calculated. So this is X XOR Y. Then this is XOR Z2. Yes? Now this X XOR Y, this is going to be 0. So this is totally removed. Now you have basically the equation X equals to Y XOR Z2. In which again, if you do Y2 XOR both sides, then you will receive, not Y2, Y XOR both sides, then will you not receive Z2 value as Y XOR X or X XOR Y simply? Now did we get this? Yes, all right, Mohit. Mohit got it. Let me increase my... All right, so I think we got this. We got this mathematics. So that means I have my Z2 value also as X or Y. Now, can everyone think the Z3 value? Can anybody tell me the Z3 value? Z3 is also X or Y. Correct. This is X or Y. Yes. This is X or Y. This is X or Y. And what about Z3? Isn't this also X or Y? Do I need to prove Z3? Totals or Z2. Exactly. Yes. So don't you think the three compartments I just created, all of them have same XOR? XOR Y, XOR Y, XOR Y. That means the condition is, if you were not finding a segment XOR as 0, then you should find an index I1 which has a XOR equal to net XOR till R, that is Y. And you should be able to find a index I2 which has a XOR value X, that is the segment XOR from 0 to L minus 1. And this I1 and I2 should be such an equality, such that I1 comes before I2. If this case is true, if you're able to find such a thing, then don't you think your answer is yes? Because don't you think you will be now be able to place such segment creations and you will be able to create equal segments of XOR Y, XOR Y? Yes? Does everyone agree with this idea? Repeat if possible. All right. If I am able to now find, like, how did I start it? I assume that there was an index in this segment from L to R for which the total net segment XOR from 0 to I1 was Y. And then I assumed there was also some I2 coming after I1 for which there was a net sum XOR X. And then when I assumed this, I was able to see that if this was true, then I was able to create three segments which had a XOR X or Y. So my assumption If I have assumed this, now I can prove this. I can say now that because I assumed this was happening and I was able to create 3 segments having same XOR, XOR, Y, XOR, Y, XOR, Y, then that means if I am able to now find an I1 and I2 such that this happens, then I will print the answer as yes. And this is arguably the best possible case. Yes. This is arguably the best possible case. Is the problem clear to everyone? This problem can go totally over your head if you are not able to follow up every statement. I'm trying to go very slow. Are you guys able to follow with this problem? All right. I think that's clear. So now once this idea is clear, can we now look into the implementation part? What I can do to implement this out is I will take the array A that is definitely there. And then I will create a prefix XOR array. So I can call this PF, or you can call this as prefix X or prefix XOR. You can even call this as PFX. And then what I'll create a map of long as a key and a vector long as a value. What is this going to save? This is going to save all the indexes in the array A up till which the prefix XOR was some particular value. Let us see how. In this map, initially what I'll do is I'll push back the initial value, that is creating a 0 prefix XOR. If I want to create a 0 prefix XOR, that means let me take nothing. And now this is a 1 base indexing. All right, I'm taking n+1 type. So I'll say that I will push back in 0 key the value 0. So in the 0 keys vector, there would be a value pushed back that is 0, which will denote that if you want to create a prefix XOR 0, don't take any element. Is this clear? That is the meaning of saying that you did not take anything that is like the segment over here. This segment means nothing. Yes. Now what I'll do further, I will run an iteration from 1 to less than equal to n, right? I'm doing a 1 base indexing. I'll take the input of AI and then I will run the prefix I. So prefix XOR. So prefix XOR becomes, why I'm creating prefix XOR, is this clear with everyone? Because like I want segment XORs, that is why I'm creating prefix XORs. Yes. We just discussed this idea previously. Like I wanted to create a XOR till like X XOR means A1, A2, A3 XOR. Y XOR means A1, A2, A3, A4, so on to AN XOR. So I want prefix XORs. Yes. So I'll create a prefix XOR array. Prefix of I XOR is prefix of I-1 XOR AI. And then I will push back in the map that my current prefix XOR value, that is PFX of I dot pushback I. That means if I had to make a prefix XOR I would require up till this I index, all the values. Now, why have I done this? When I will now do this pre-computation, when I run my iteration in the query, take the input of LNR and the X, what I'll do initially, first I will like, I have a value X with me. All right. So I have declared an X value with me. And now I will make my X value as, or you can directly do something like this also. That's also good to go. X will become equal to prefix of R XOR prefix of L-1. Is there any doubt in this? This is the segment XOR. If I want the segment XOR, this green part I marked, I want the XOR till R XORed with the value of XOR prefix XOR till L-1 range. Yes. Do I want this? So that means prefix of R XOR prefix of L-1. This gives me the XOR of the segment. That is X. Now, if the XOR segment is 0, answer is yes. Is that correct? Answer is yes. We just calculated this base case. And if that is not, and you can continue, if that is not the case, now what do you want to do? First, I will extract the vector of all possible indexes having the prefix XOR till R. This is calculating the prefix XOR till Y. So all the indexes which can have Y value. Same, I will calculate all the indexes which can have a total of X XOR. That is till X XOR, that is L-1. So MP of PFX of L-1. I extract these two vectors, V1 and V2. Now I'll run a lower bound on both of them. How do I do that? Lower bound means I will calculate the first index after L in the IT1, in the V1 array, which gives me a prefix XOR of X. So this is the calculation of I2. Yes. Or if you don't get confused, what I can do is I can make this as I2. I can keep this as I1 if that is not confusing. Or even like by this also you can understand. I create an iterator, like this can be IT1, you can call this as IT1, and this can be IT2. So you call IT1, you calculate IT1 by finding the lower bound, that is the just next greater value on, we understand lower bound, right? Call lower bound on all the possible indexes extracted from the prefix XORs of the net value till y. What does MP variable? Map of XOR values till I. No, MP variable is the map of the type long comma vector long, which represents that for a key equals to prefix XOR, in its corresponding vector, you will have all the indices till prefix for which you have created that prefix XOR. All right, Mohit. So let's say in this case, I was able to create up till here, I was up till, let's say here, up till here I was able to create X. Let's say up till here I was able to create X. Let's say up till here I was able to create X. All these indices will be saved in that map corresponding to the X prefix. Clear? Got it? Now, I will calculate the lower bound on this, and similarly, I will calculate the lower bound for IT2. This is going to be this IT2. This is IT2. IT2. I got confused a bit. This is IT1 and this is IT2 only, right? Don't get confused. I got a bit confused by looking at the code. But as we discussed previously only, I am trying to calculate two indices. So this is IT1, or this is I1 rather, or IT1, whatever you can call this. And this is IT2. And now when I calculate IT1 and IT2, I am also calculating IT2 minus. Why is that? Because this is the just next greater value and I don't want to exceed the R range. That is why I'm doing R minus. Now, when I dereference both values out, I will say that when I dereference both of them out, it gives me the indexes. If I got an index IT1, which is lower than IT2, that means I received an IT1, which is coming, like this blue stick is coming before the green stick. That means I was able to create 3 compartments, which would had the XOR X and XOR Y. So I would print a yes, else I would print a no. Is this clear? Is this clear to everyone? Yes? If for k equals to 2, 3 is not only, how is the kinetic direction? Also, Sai Vishwas, that's the argument, right? Like, let's say you are not able to create an answer for k equals to 2 and k equals to 3. Then for k equals to 4, how would you create such an answer? Like, like this can be proved by induction, I think. Like it can go for a long proving. All right, like what can happen is like a general argument. All right, how can I reason this? All right, let's say for k equals to 3, you wanted such a case where we just saw, right? X or Y, X or Y, X or Y. Let's say you want, like, let's say you argued that there did not exist an answer for k equals to 3, but there existed an answer for k equals to 5. That means you had 5 segments, right? Yes, 5 segments. Now, in those 5 segments, don't you think those 5 segments are going to get incorporated in these 3 segments by induction? Can you imagine this? So if you think you were not able to find an answer for k equals to 3, how will you find an answer for k equals to 5? Like, try to think this by induction. But I can't imagine. Like, I can't think of a test case currently, like right now, to actually prove this out. Maybe like you will find a good proving for this in the tutorial part. All right. Maybe in the editorial part, maybe there'll be a good mathematical proving to this. Like, I did not actually think for a mathematical proving to this, because by induction, I can see this is going to happen. Because for like k equals to 3, the answer is not possible. Higher values will never be possible, because lower the segments you break, lower the XOR values you create. And XOR values is something I want to create in like shorter segments possible. So like if k2 was not possible, I went to an argument that k3 would be possible. And if now k3 is not possible, anything beyond that will never be possible, because I will never be able to bifurcate the elements into that part. All right. All right. Okay. So now is the whole code clear to everyone? Now, if I discuss this time complexity, what do you think is going to be? Like, you have an order of Q over here that's getting followed, right? This is O of Q. Inside this, everything is pre-computed except this lower bound. So this lower bound is getting calculated. Now tell me, lower bound maximum size can go what? Like I have then n order. Max case can be all n's were present in this V1 array. So you can have log n inside this, right? Similarly for this can also be log n. So the maximum order you actually have, the superseding term of order which you have in this time complexity is actually q log n. Because everything beyond this is actually simply like even for map also, like because I'm taking an unordered, like I'm taking a map. If you take an unordered map, maybe things will be much more simpler in time complexity. But if you're taking a map, even for this loop, you are having an n log n creation. Yes, because n is the number of times I'm running an iteration, and then inserting something new or updating something in the map of a normal type is actually log n. So you can take a complexity as n log n plus q log n, in which both things are like whatever is the superseding term, it works because both are in a very like in a good order, right? Q log n or n log n both works for 10 power 5 order. Is this clear? We are finding first index from map which lies L to R for both x and y. Correct, Mohit. Exactly. So I hope this problem has now become clear. Now it's a typical problem to like implement. I agree that, and you should give it a try yourself. And you will argue that like you will be able to find your correct answer in that case. Like if this can be implemented even with sets in a lower bound, even like you can implement a direct binary search, not take a lower bound into consideration, but you get the idea, right? Can you move on to the final problem? It's getting pretty late. I'll try to wrap up the last problem in like 10-15 minutes and then we can end, right? We started off, I think, at 11:15. 12:15, 1:15, 2 hours. Last problem. All right. All right. Division plus LPC, easy version. So in this easy version, L is equal to R. That means even if they give L, even if they give R, it's not a problem for me. All right. So now I'll try to roughly dictate the idea in this particular piece of approach, and we'll see what happens. So our target is to create, like, break down rather the S string. So this is S1, S2, S3, S4, so on till Sn. I want to break this into K parts. Let's say K is 4. So I want to break this into 4 continuous parts. And for those 4 continuous parts, the prefix, I would find the length of the longest common prefix. Length of the longest common prefix and all those broken parts. Longest common prefix and all those broken parts. And then my target is to actually maximize this longest common prefix value. Is this clear to everyone? Yes? So question is, I think, pretty clear. Everyone must have read the question and they must be pretty clear about what is happening in this. Now I'll try to dictate some ideas. First idea, I'm trying to reduce, like, I know I'm not, I like for leftover guys in this also, and people who must have reached this part of video, I know I don't need to discuss a brute approach with you because you can very well see that a brute approach will give you a TLE. Whatever brute force approach you actually come up with, you will get a TLE. Yes. So what I'll do is I'll try to optimize stuff and then tell me if you can imagine this. First thing I'll try to, like, there are 2 parts to this brute approach. First thing is this prefix, like LCP number, this number can range anywhere between 1 to L. Yes, 1 to N, sorry. LCP number can range anywhere between 1 to N. The longest common prefix you can form can be anywhere between 1 to N. Yes. Is that right? The search space or the space of LCP existing is 1 to N. It will be somewhere inside this. Now, the other thing is, let's say I argued, let's say I told you that the maximum longest common prefix you could have found was 3. Then how could you have cross-referenced this? My answer question is this. Like, let's say I gave you a string. This was S1, this was S2, this was S3, this was S4, this was S5, this was S6, this was S7. And let's say L was given 2 to you. Then don't you think the argument is, I want to find at least L non-intersecting segments of length. Let's say I argued that the answer was 3. So length 3, which have the same string. Do you think this argument is right? if let's say I argue that the LCP value was 3 and L was given 2 to you, then that means you want to create at least 2 non-intersecting segments of length 3, which have the same string. Why? Because let's say the segment from S1, S2, S3, and let's say the segment from S5, S5, S6, S7 was same. Let's say this was also ABC, this was also ABC. Yes. Then you can see the LCP is 3 currently. Then what segment can you actually take? You want continuous segment. So can you not increase this window from this to this? Even if you do this, take this one window, take this other window. In this, will you not find the LCP as 3 because ABC match? Yes. Are we clear on this idea? So my argument is I somehow want to find at least L non-intersecting segments of length 3 which have the same string. And then this can range, this LCP value can range from 1 to n. So this is idea 2, I just put it on the next page from page 2. And this is the first idea. So now we'll try to optimize both ideas. In the first idea, you know that you will have a complexity of O of n. Let's say I tell you the ranges are from 1 to n, then you will say, let me implement a loop from 1 to n. But can you do that? You cannot do that, right? Because n is an order of 10 power 5. If you do that, you will exhaust almost very large chunk of your time complexity. Yes? Is this clear? So that means what I can do, I should not take O of n into consideration. What I'll do, I'll argue one more thing. Tell me one thing. If I argued that the LCP was 3, then can't you tell, like, can you tell me, like, do you think the LCP 2 and 1 are also true? If I argued that LCP 3 was true, or there was an existence to create an LCP 3, then don't you think an existence to create all the LCPs before LCP 3 were also true? Yes. Yes. Is everyone agreeing with this? Agreed? That means why? Why is that? Because like, let's say LCP in this case was 3, ABC matched. If I argue LCP 2 should match, you can say, yes, AB will match. This is LCP 2. If LCP 1 has to match, yes, AA will match. This is LCP 1. So argument is, I can see a predicate logic. If from a search space from 1 to n, let's say I'll name this 1, 2, 3, 4, so on till n. If I keep this as an L, I keep this as an R, I can binary search on the LCP length. Can I not? If I receive a mid length, for this mid length, if I somehow am able to find an answer true, then all the answers previously, will this also be true? And all the answers, if I'm not able to find an answer from mid, that is, if the answer for this is false, then all the answers above this will also be false. If I'm not able to create a mid-length LCP, then will I be able to create a mid plus 1, mid plus 2, mid plus 3, so on till R LCP? No. Is that yes? Do we agree with this? So can I see a predicate sort of a monotonic function in this, that the order is somewhat like true, and then there is one false, and my target is actually to find this appropriate true value for which the length is maximum. Yes? Agreed? That means I can boil my complexity from O of n to O of log n from this part. This can be implemented with binary search. Now the next idea. If now I've understood binary search, other part is the checker function. All right, you said that fine, you somehow came up with binary search, but what about the checker function? How do you actually take up an LCP and argue yes or no for that current LCP? What I want to argue, I have stated in blue. I want to argue that if you have fixed your LCP, you want to create at least L non-intersecting segments of length. In this case, now it doesn't become 3. You have a variable LCP which have the same string. That means you want a naive check of comparison of strings. So I think somebody pointed out this in the chat that you can use KMP. Exactly. The point being that now you want to naively check strings. Naively check strings, or check rather segments of strings. Is that right? Yes. You want to check segments of strings and you want to see whether they are equal or not. If you're able to create greater than equal to L segments, then you will be good to go. Non-intersecting segments. So if you actually implement any string matching algorithm which gives you the capability to find this segments in a better time complexity, but rather than a naive check, you will be good to go. Is that right? So one of those things is KMP, definitely Rajat. But how did I implement this problem was simply by string hashing. So are you guys familiar with string hashing? So now string hashing is a very basic logic as compared to KMP. String hashing works on the case that what I'll do is I will say that, let's say there is a string ABC, there is a string BCD, there is again a string ABD. I will allocate them, these three strings, three unique hash values. I will say this is, I will dictate that this hash value, this A string will now be represented always with a unique hash value, let's say 0. BCD will always be represented with a unique hash value 1. ABD will always be represented with a unique hash value, let's say 2. Now, if I would have asked you in this three strings, does a string BCD exist? Naively, you would have compared every single character with every other string. You would have gotten a very large time complexity. But now you will not do this. What you will do this, using that similar hash function, you will calculate the hash value of this. You will calculate the hash value of this, and you will say that hash value of this will turn out as 1. Because I know this hash value is same. Hash function is, same. So if I find a value of 1, now what I'll do is I'll compare 1 in this set, 0, 1, and 2. I will know that 1 exists over here. That means BCD matches. If let's say this was a string, something like let's say ECD, then this would have given me a hash value, not 1, something else. Maybe let's say some other hash value. Let's say some other hash value 3. And 3 would have not existed in the existing hash values. So that would clearly mean that I have nowhere to go, and I know ECD doesn't exist in this limit. This topic is called string hashing. Clear? How do we handle collision? All right, so collision is handled by taking big primes. I'm not going to go in a very complex data structure of string hashing, because what I'll do is when I stick the code piece after this video, you can, like, it is a recommendation by me that this is actually Priyansh's code only for all those guys who watch this video later. This is Priyansh's formed code from his GitHub actually of string hashing algorithm, which is actually somewhere covered in later classes also. But this piece of code is actually a boiler code. Like, I will give you a boilerplate code to actually implement string hashing. From now on, whenever you want to implement string hashing, you will be able to do this. So what this code does is, this boilerplate code which we have created, this will give you the feasibility, all right, feasibility to calculate in O of 1 the hash value between an L and L comma R index in a string. So if let's say the string is S1, S2, S3, S4, S5, so on till Sn. If I ask you what is the hash value from S2 to S4, you will pass in this function 2, 4, and out it will pop the hash value. Now imagine such a function is given to you. Don't you think your question will become very simple now? Because what will be left for you to do? You will do something like this, that you will start off with a segment of LCP. Let's say LCP was 3. So you will find the first 3-lengthed hash value. Let's say this hash value was H, or let's say H1. And then what you'll do is you can run 2 pointers. You can keep L over here, R over here. Next time you can keep your L over from this to L over here to R over here. And then you can keep on checking the hash value of this segment, L to R. If you find this hash segment to be equal to H1, you can move your whole window by the LCP size, or you can simply move your window by 1 size. Does this make sense? Let us look at the code and you will understand this. All right. So like, I will not go to the hashing part. Just imagine that this hashing function was well dusted for you. What happens now? Straight time complexity. All right, I'm coming to that part. Let's say you took n, then I have 2 variables. I took k and kc. All right, both are same, so that's not a big deal. I just wanted to take 2 variables. So I took because like they were talking about consecutive k part. So I took one variable as k, another part as copy of k, that is kc. All right, so naming is just done by me. If that you can do some better naming, that's all good to you. Take the input of n, k, and kc, then take the input of string. Now I will pass this string to the hashing function. So I have created a hashing structure over here, and don't go into the logic. How is this done? I will come to that part. Just imagine somehow by doing this, you now have an object h of this hashing structure, which has the capability to use a function called substring hash, takes ln and returns the hash value. Can everyone see this piece of code? I will zoom this out. Yes. So what will happen is, after I've done this, I can run a binary search. Start off with the binary search, take low as 1, high as n, and then answer starts with 0. That is the possibility where you get LCP as 0. So you begin with answer as 0. Begin with the binary search, low is less than equal to high. Take a mid, low plus high by 2, or this can be left shift 1. Now take a C variable, that is the count of segments. This starts with 1. Initial segment L is 0, R is mid minus 1. So this is L is 0 to mid minus 1 range. Calculate the hash of this. So hash of this is going to be calculated like I have taken two M's, M1 as 1 M1 is 10 power 9 plus 9 and one M1 is 10 power 9 plus 7. That is why I'm getting a vector of hashes to actually remove collision. But even you can work with one hash. That's not going to be a problem. All right. So you will get a vector of two hashes so that you get double hashing. Exactly, Mohit. You get a double hashing logic. You calculate this as a checker hash. This is a checker hash. You can call this as hash check. This is the segment check which you want to create with. Now what you can do is shift L to mid and R to L plus mid minus 1. This is the next segment, just next segment of window because this is non-intersecting. Now run a while loop, two-pointer approach. R is less than N and L is less than equal to R. If you see that the current hash from L to R is equal to this current hash check, then you can increment C by 1 because you have founded one more segment. Make L as R plus 1. You shift L to the next index of R plus 1. R next to R, that is R plus 1. And you shift R equals to L plus mid minus 1. That is the next segment length. And if this is not the case, then you only move by 1 time. So you will increment only L by 1 and R by 1. Yes. Then when you come out of this logic, if you think that your current segment count is greater than equal to K, that means this is a potential answer. Store this and make your low equals to mid plus 1. Because we just saw that a predicate logic was true, 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 false. That means low has to be greater. Low needs to come forward if I found the mid as true, or R has to come backward. And then I can print answer. Is this clear with? Is this good to go? Now, if I calculate the time complexity, this hash calculation is actually O of 1. So if you actually calculate that time complexity now, you will say that this binary search logic is log n, and inside this while loop is actually a two-pointer approach which can run in maximum of O of n complexity. So you can say that overall you have a O of n log n solution. Is that right? Yes. And this hashing structure which we just calculated is actually O of n. Now, why is this O of n? Like, I don't want to go into the very deep structure of hashing, but this template is somehow made in such a structure that we are calculating O of n. Now, I will discuss very small part of this. Base for this is 31. I have taken two hash primes. Now, in this, you can see that the hashing structure I have created, I am calculating for two hashes. And you can see I'm running two loops, 1 to n, n minus 1 to 0. So overall, this hashing structure is calculated in O of n complexity. All right. That is why you are having an overall structure of hashing as O of n. So overall, you can say that I have an O of n creation time to create the hash out of str, that is the string, and then everything besides that is constant. Because then you can see everything is very well pre-computed. In this, you can see I have calculated val1 directly comes, val2 directly comes, then hash I also directly comes, simply addition and subtraction. So returning of this hash value is actually constant. This is how the logic has been done. And this is such a good, nice piece of code that you can actually use this in your further questions also. So you'll never require KMP or anything like that. All right. All right. So now once I've done that, now once I've calculated the hash, this is O constant. This while loop is O of n, that is the two-pointer approach. And then this is n log n. All right. And this works for the answer. Now, if you're not able to find any answer, then answer will be 0. So you will get answer for 0 also. And if to answer some like LCP length, which is true, you will calculate the best possible LCP length. And this gives you the right piece of accepted code. Like you can see this is accepted. So what is the time complexity now for this? Time complexity is going to be O of n log n. And then this is space. Space, what is space going to be? Space is going to be O of n. Why O of n? Because like you can see over here also in the hashing structure, we have created vector of vectors. And vector of vectors size is actually n into 2 because we only have 2 hash primes. So this is almost n. And you're using them to actually calculate the hash values. That is why O of n is a approximate size for the space also. So good to go. Now we have a logic in n log n. Now, do you think n log n will work? Yes, it will work. Correct? So fun problem, right? All right. So this brings us to the end of our PCD discussion. We have discussed almost every problem except G2. All right. And I can end the screen share now. Thank you for watching this.